Okay, so with related rates, do y'all remember the little acronym we used? FWIGI. So what did the F stand for? Find. When. Given. And then equation. Very good. Whoops, there we go. Okay, and so that's what you need to know for related rates. All right, so this first problem, I am going to go over this one, although this is kind of a one-of-a-kind, not one-of-a-kind so much, but this is kind of a different type problem. I don't think we've ever worked one quite like this, where we have a cone of water and it's dripping into a cylinder. So it looks really difficult, doesn't it? Yeah, okay, but it doesn't, you know, one part of this may be difficult and two parts may be really easy, so don't give up on yourself before you get to it. So it says, as shown in the figure, water is draining from a conical tank with height 12 feet and diameter 8 feet. Okay, this information right here is only there to give you the ratio. The ratio of radius to height. When you're dealing with cones, this whole proportion thing, sometimes they give you an equation, like the radius is 3 times the height. Sometimes you have to find the proportion. Okay, so what would the proportion of radius to height be?
8 to 12.
Okay, so 8's the diameter.
Oh, sorry, 4 to 12.
So 4 to 12, are y'all okay if I write it as 1/3?
Mm-hmm.
Okay. So you could solve for r from here, solve for h. You could find dr over dt or find dh over dt. You could find all of that stuff from this proportion. I'm starting with this because this was the part that a lot of students would forget about. They would be working through the problem and then you forget about this, so I'm just going to go ahead and get this out. You will not use 12 or 8 anywhere else in the problem. Okay, it's not part of the given, it's not part of the when or anything. All right, we have a cylinder, and then that cylinder base, okay, basically this area, and I'm going to use big B here because big B stands for area of the base. You could definitely say that pi r squared is 400 pi, so what would r be on the radius? I mean, the radius of the cylinder be? 20. Okay, so if you needed to figure that out, you could. This may be all, this ends up being all you need. So it says the depth h in feet of water of the conical tank is changing at a rate of, and then they give you dh over dt. Now keep in mind here, h is the height of the water in the cone, not the cylinder. So, and then they say the volume of the cone. So here's your equation. So part A doesn't really even get into FWIGI yet. Part A is trying to help you make this equation easier, because if we were, what do you have to do with the equation in related rates problems? You have to derive it. And how would you derive this equation? What rule would you have to use? Product rule. And you need to know dr over dt and dh over dt, and it'd be more complicated. All right, but they're trying to help you out here by telling you to write an expression of the volume as a function of h. When they say as a function of h, it means there's not going to be an r left in the thing. Sometimes it's like just in general, sometimes you want this as a function of h, sometimes you want it as a function of r. This is not why how I taught you how to do this. I taught you just to do the product rule thing because you don't know. But since they tell us to do this in part A, this is an easy point and it's going to help me. So what I need to do basically is just in place of r, I need to write something in terms of h. So what is it? So that has to do with the cylinder. You don't want to use that. So, and it's not a number. The radius, what they're talking about here is, if I can draw it really small, they're saying, what's this radius? Well, it's changing, right? As the water comes out of the cone, radius is getting smaller. So let's think, can we write r as a function of h? So think, well, we haven't used this proportion. Yeah.
I thought we were finding the expression for the volume of water in the tank, like the...
Okay, but what we got to do, we got to go, on A, they say write an expression of the volume of water in the conical tank. I mean, by conical, they're meaning cone.
Oh.
So, look, we're still up here. We haven't gotten to this, and I get what you guys are saying, and that'll come in part C when they bring up cylindrical tank. Okay, but we can just totally ignore the cylinder. Yeah, we read the problem and we wrote down what we needed, but to do what they're asking us on part A, we need to stay in the cone. So in the cone, how can I rewrite r so that it's only in terms of h? 1/3 h. You're getting that from the proportion up here. If we were to get r by itself, it would be 1/3 h. And this is really easy to miss. All right, but use that proportion. And so I'm going to write it as 1/3 h. So here's the thing, this is why they want you to do it, and this is why it's helpful for you. On part B, they're going to say, what is the rate of volume? So on B, you're trying to find dV over dt. That means we have to derive. This thing, although I could simplify it a little bit, which we're going to do, is a lot easier to derive than what you started with. Okay, so let's simplify this before I go any further, because we know we're going to have to derive it, so let's just go ahead and simplify it. So 1/3 pi, 1/3 square, that would be 1/27 pi, and then h squared, h cubed. Okay, so let me just say it one more time why they did this. This is a lot easier to derive. You only have to deal with h and dh over dt. We are no longer in the problem going to have to deal with radius at all. All right, let's finish the Fuigi down here. So when h equals 3, and then if you want to write down the givens, you can. The given really is right here. Usually the given is a rate, almost always. And then the equation, we are going to use our brand new equation for volume, which is going to be 1/27 pi h cubed. If you wanted to, you could use the original equation. You would just end up doing more work than everybody else. Everybody with me so far? Any questions? Okay, so like you guys said, we have to derive this now. All right, so I'm going to do this over here. So when I derive v, I get dv over dt. Okay, and what is this whole right side derived? What's the derivative?
1/9 h squared.
1/9 pi h squared, just using power rule. Don't forget that you got to write dh over dt. In related rates, anytime you take the derivative of a variable, you got to do this. Because we're taking derivative with respect to time. And so any variable that's not t, we need to do this. Okay, so dv over dt, that's what we're looking for. So all I got to do now is plug in, okay, my h is 3. And my dh over dt is h minus 12. So what am I going to write here? What's h?
3.
3. So instead of writing h minus 12, I'm going to write 3 minus 12, or you could go ahead and write -9 if you wanted to. And you could do this without a calculator. It is quite possible this would be on the non-calculator part. And so you get -9 pi. Here's how I did it. 3 squared, 1/9, they canceled. -9 pi. We do need to put units. So this is dV over dt. Change in volume over change in time. So what would my units be for volume? Be what? Cubed. And then over dt, so time, and that would be minute. So that's how you get that. So I'm going to say this one more time. If they did not have this part A, we would have had to do product rule up here. And when we got to the dr over dt, I would have had to derive this. dr over dt is 1/3 dh over dt, and dh over dt is h minus 12. And it would have been it would have been a little bit more complicated. But by putting part A in, it actually helped us with part B to keep it simple. Yeah. You can. The thing is, you have to decide if you want to, if you need to get it in terms of H or terms of R. It depends on the problem which one you want to do. If you can look ahead and it makes sense, like, oh, this one's going to be in terms of H because I mean, that is how some teachers teach it, and some teachers like me just say every time use the product rule. That way you're not having to guess which one.
Like if you're given dr over dt, there's r probably.
Yeah. Okay, so now, so both of these parts, again, this is kind of a weird problem, but notice we haven't even talked about the cylinder in these parts yet. Only part C is the only one. So they're saying let y, so we're going to let y be the depth in feet of the water in the cylindrical tank. At what rate is y changing? And I want you, this should be y equals 3, not h equals 3. Because h is the height of the water up here, which I guess we could do that problem, but it should be y equals 3. So let's go through our FWIGI. Now, if you feel like you've advanced beyond FWIGI, be my guest, as long as you're getting the right answer. But I think it's not a bad way to write it out. So what's our find, though?
dy over dt.
dy over dt. What's our win?
Y equals 3.
Y equals 3. What's our given? All right, so here we have to think, and let me back up just a second. I'm going to leave this as h because it could be that y equals this, but I really do need this. I'm sorry. Because when h is 3, I'm going to use this same problem. I'm sorry if that confused y'all, that change. We'll just leave it the way it was. Because when h is 3, you know the change in volume out of the cone, right? That cone is losing water at 9 pi cubic feet per minute. So at what rate is the cylinder gaining water? 9 pi, positive 9 pi cubic feet per minute. So our given, it wasn't obvious, but our given is our dV over dt is positive 9 pi. And that's why I was saying you need the h equals 3. I'm going to show you something in a minute why. Well, let's just continue in the problem. So what would be the equation for the volume of the cylinder?
Area of the base times height.
Area of the base times the height. So this is why I didn't really bother too much with finding the radius of the cylinder, because here's big B, there's big B, all is good. Okay, I'm going to erase this over here so that I have more room for this problem. Okay, so we know we have to find dV over dt, or we have to derive. Now, is big B a variable or is it a constant? It's a constant. Okay, I want to show you something. Let's say you didn't recognize that. So we are going to be able to just change this to be 400 pi. We don't have to keep it as B. But let's say you didn't notice that. Or in another problem, it isn't constant. You would have to use product rule here. And so I want to make sure that everybody's good with product rule, even though it's a little unnecessary on this one. Okay, so we do the first one times the derivative of the second one, plus, and then you do the derivative of the first one times just the second one. All right, now, what's dB over dt? If this thing's not changing,
0.
0. That's 0 right there. Okay, so this whole thing ends up canceling out. And dV over dt is 9 pi, V is 400 pi, and dH over dt, we change this back to H, that's what we're looking for. So what I want to show you here is that if you had recognized, oh, I can actually plug in the number before I do the derivative because dV over dt is 0, this thing's not changing, you would have saved yourself one tiny step. But if you didn't notice it, it's not too bad. But you did have to know that dV over dt is 0. It's not changing. That base is going to stay that shape forever. Okay, so then final answer. What's dH over dt? Without a calculator.
9 pi over 400 pi.
9 pi over 400 pi.
9 over 400.
So I'm just going to write it's 9 over 400. Although you could write 9 pi over 400 pi, and that's right. You don't have to simplify these. And then it's dH. It's not volume or anything. So it's just feet per minute. All right, this was a difficult problem. Like when you look at it as a whole, it is difficult. But I like it because it reviews a lot of different aspects. So now what I want to do is go over a really easy problem. That's very common, and this is a ladder problem. The ladder sliding down the wall. So I want you to turn to number 8. So on number 8, we have a ladder that's leaning against a building. What shape is this making?
Triangle.
What kind of triangle?
Right.
A right triangle. Uh-oh. Let me redo that. And the ladder is the hypotenuse, so I'm going to go ahead and put 26. And I'm going to go ahead and label the 3 sides, A, B, and C. Okay, so then it says the foot of the ladder moves away from the building. So the ladder is sliding. Ooh, my pen keeps catching, sorry.
dB over dt.
It's going this way. So dB over dt is positive or negative 3?
Positive.
Which one? All you gotta think is B getting bigger or smaller? So positive. Away kind of makes you think negative, but if B is getting bigger, then the change is positive. All right, it says the foot of the ladder is 10 feet, or when the foot of the ladder is 10 feet from the building. Find the rate in feet per second at which the top of the ladder. So what is sliding down the wall? So what are we trying to find here?
dA over dt.
dA over dt, which do you think that's going to be positive or negative?
Negative.
It's going to be negative. Now, if you notice all your answer choices are positive, I'll explain that in a minute. All right, the when, if you wanted, I mean, really it's all on the picture, so you could just say, oh, look right here. But what's my equation?
C squared.
Yeah, Pythagorean Theorem. So a squared plus b squared equals c squared. And the nice thing about deriving Pythagorean Theorem is it does the exact same thing every single time. So derivative of a squared is 2a dA over dt. You just take the derivative, and again, every single time you take the derivative of a letter, you got to write d, that letter, over dt. So what would be the derivative of b squared? 2b dB over dt. And the derivative of c squared? 2c dc over dt. Now the nice thing is they all have a 2, so you could actually totally cross those 2's off if you wanted to. Alright, it's just like dividing everything on both sides by 2. I'm not going to do that because I just don't think that's like something a lot of students think to do. Alright, so now we got to fill in what we know, what we're trying to find, identify what we're trying to find. And so A, whoop, I'm already to the first one. When B is 10, what does A equal? Now, this is a no calculator problem, by the way. So this means that it's probably a Pythagorean triple. So what are our Pythagorean triples? So those are special right triangles. Let me give you the first one, 3, 4, 5. Or any multiple of 3, 4, 5. You remember the next one?
5, 7, 12. Or 5, 12. Yeah.
And then the only other one that I see pop up is 7, 24, 25. And then any multiple of these. This is going to save you a lot of work because I don't know about you, but I do not want to be squaring 26 and then doing stuff with that number and then having to square root another number. All right, but which of these triples do you see?
5.
Yeah. So 5 times 2 is 10, 13 the hypotenuse times 2, so 12 times 2, that would give you the missing side. All right, so we need to do 24. dA over dt, that's what we're looking for. Let me erase that. So dA over dt, okay, B is 10, dB over dt is 3, 2, 26, and dc over dt is also not given, but since this is representing the ladder, it doesn't change at all. And that's true of all these ladder problems. You're not going to get an extendable ladder problem. Don't worry about that. Okay, so look what happens to that whole side. 0. So this is something you could do without a calculator, even if you didn't divide by the 2. Okay, you subtract that over negative 60. So then you divide by 48. And what does this simplify to? 5 over 4. Now the reason your answer choices are all positive is the way they worded the question. Find the rate at which the top of the ladder is sliding down the wall. So the question is implying that your answer is negative, and it's really just saying, well, what rate? Almost like speed versus velocity. It's kind of like saying, what's the speed of this thing? All right, so that's A. Now I'm going to let you in. Well, some of you know this, but do you see any 2 answer choices that look almost identical?
A and C.
You could say A and C. I'm thinking A and B. The only mistake you would get if you did B was you got here and then you just divided the 2 wrong numbers. That would be something anybody could possibly do if they weren't being careful. Okay, when you're taking the AP test, you need to be able to work these problems. But when you get to a problem and you just have no idea how to do it, or you're running out of time, and you see 2 answer choices that look like they're the same, like you could get one or you could get the other if you make some really small mistake, it is probably, I'm not saying for sure, but it is probably one of those 2 answers is correct. So you should guess one of those 2. All right? So I want you to look really quick and see if you can find any other Pythagorean theorem problems. Look in your packet and do yourself a favor and just write PT next to the Pythagorean theorem problems. As you can tell, this really isn't that long of a passage. So we're only spending one day. So which ones did you find were Pythagorean theorem? Okay, 9 is. Number 11 is. Number 14 is. Number 4.
Number 6 Pythagorean theorem.
Number 6 is not Pythagorean theorem, and that's the one I'm going to work next. It is a right triangle, but it's not Pythagorean. It's a shadow problem. And then look, if you look on the first page, 2 is also a right triangle, but there's a theta in there, so that's a little bit different. So we're going to actually look kind of at both of those problems. Also, by the way, before I forget, actually let's just go back and do 2 next. We'll just do this order. By 3, I just want you to write bonus. Here's the deal. If you're shooting for a 5, you need to do 3. You need to try it. It's not really that hard. It's kind of clever, and it is tedious. I would rather, if you're like, I can do the rest, but I cannot do this, you're in good shape, okay? I don't want you to spend your time on this one and at the expense of not doing other ones. All right, because this is kind of like, it's a great problem, but I'd rather you spend your time on problems like 2. Okay, so this is the right triangle, but I already told you it's not Pythagorean theorem. So let's think about, what are we trying to find? In the triangle shown, if theta increases at a constant rate of 3 radians per minute, at what rate is x increasing in units per minute when x equals 3? We're trying to find dx over dt, the rate of change of x. What's our when? X equals 3. It's kind of nice that they use the word when.
Yeah.
It kind of clues you in. And then our given is going to be this rate. D theta, it says theta is changing, is increasing, so positive 3. But theta itself is getting bigger and bigger. So this triangle is kind of opening up and it's getting really tall and skinny. All right. Well, it's not really actually getting very much taller because this 5 is set, but that's neither here nor there. All right. So what's our equation? If it's not Pythagorean theorem, what's our equation? How are you going to write an equation between theta, x, and phi? What's the relationship? Sine. So sine of theta is equal to x over 5. All right, so now let's think, okay, now we got to take derivative. So what's derivative of sine of theta? Cosine theta, and you got to write times d theta over dt. Even here, you got to write that. And we have it over here, so I knew I probably needed to use it anyway. What's derivative of x over 5? Do I need to use quotient rule?
Oh, wait.
Could I not just rewrite this as 1/5 x? Yeah, you could use quotient rule, but you would be doing a lot more work than the rest of us. All right, so moving on, and I'm just going to write over this if that doesn't bother y'all. Cosine theta. I wish I knew this. But remember, we're doing this whole problem assuming that x is 3. So what's this missing side? When x is 3, the base is 4. Again, a triple. So what's cosine of theta?
I got 5.
We'll get there eventually. 4/5. So 4/5 times d theta over dt is 3. That equals 1/5 times, and then dx over dt is what we're looking for. So what's dx over dt? Without a calculator, you could do this. This could be on the non-calculator part.
66.
Which is?
12.
Okay? So the whole thing of this is you had to come up with sine theta. From there, it was more or less downhill. All right, turn the page and let's look at number 6. Okay, so on number 6, this is the last one we're going to do today. First of all, you have 5 seconds left on the AP test. You have no time to read this problem. You're going to guess B or C. I cannot promise you that one of those is the right answer, but I can say that more times than not, that's how, that, and sometimes you don't get that option, but on these, and it is B or C, it is one of these two. I'm not going to tell you just yet. All right, so one's 4/3 and one's 3/4. Oh, okay. It's just because of the way they write multiple choice and have distractors. If you see 2 answers that are really similar, probably it's one of the 2. So at number 6, we need to draw a picture. We've got a person. They're 2 meters tall. There's a street light. That's 8 meters tall. And they're walking away from it. Okay, so here's the I don't like that. So here is the street light. It's shining brightly. It's like a sun. All right, and then here's the person. They're 2 meters tall. I'm not going to draw them. All right, and they're walking away from the street light. Okay, so what I'm going to do is I'm going to kind of just connect everything else. And you see, we do have a right triangle, but the hypotenuse means nothing. There's it's not anything that they're going to give us. It's not what we're trying to find. So that's how I know this is not a Pythagorean problem. In fact, when it starts talking about if a person is walking at a constant rate and her shadow is lengthening, when you see a shadow problem, it is going to be like this. These aren't as common as ladder problems, but you could, it's not rare either. So here's her shadow right here, right? Because here's the street light, here's the top of her head, and here's her shadow. And we don't know how long her shadow is, but we know what the rate of change of her shadow is. All right? And so let's go ahead and list out our Fleety. It's like, okay, well, find the rate at which the person is walking. So we're trying to find the rate of change of this. So I need to go ahead now and put in some letters. You could pick letters. Picking S for shadow, that's not bad, but S looks a lot like a 5. So you have to be careful. I'm just going to put X and Y. And so when this says she is walking at a constant rate of 4/9 meters per second, which one of these two things are they talking about changing? Look, here's the street light, and here she is, and she's walking. Which is getting bigger? Hint, hint.
X.
X. So dx over dt, that's what 4/9 is. Now I get that the shadow is going to change length too, but that's what they're going to. Oh, you know what? I'm not. Any of y'all thinking I'm going crazy? Because I am. All right, that's going to be. Let me put the when here, and let me put the given. That's our given. I don't like that either. Okay. Yeah, let me just, can we rewind just for like 30 seconds? Alright, I've done this problem too many times today. I guess that's what my brain's telling me. Alright, so if the person is walking, we rewounded to this. If the person is walking at a constant rate and the shadow is lengthening at a rate of 4/9. The shadow is lengthening. That's why when y'all thought I was crazy.
dy.
dy over dt. That's what's given. I was kind of trying to do the f and the g at the same time. That doesn't work. All right, and so at what rate is the person walking? That's dx over dt. That's what we're trying to find. Are there any questions about that? How I knew which one was the shadow and which one was the walking? Okay. There's no real when here. All right, so I'm going to cross that off. Our equation. Now, a squared plus b squared equals c squared does not work here. And the only thing I can do is think about a proportion. Do you need something? Okay. Oh, weird. Okay, so we need to set up a proportion because this little triangle, is that the same? I mean, it is similar to the big triangle. It is, and it will always be on shadow problems. So what I'm going to do is I'm going to set up a proportion where I'm going to put the big height of the triangle over the little height of the triangle. So 8 over 2. And now I need to write an equal proportion having to do with the bases of these triangles. So what's the base of the big triangle? X plus y. It has to be x plus y, because x is just that piece. All right, and then the denominator here should be y. Okay, I'm going to go ahead and write that as 4 if y'all are okay with that. And I am going to multiply, because unless you just really love quotient rule, which I don't, if I can get out of quotient rule, I want to get out of it, okay? And so if we clean this up a little bit, we don't have to use quotient rule. Can I clean it up anymore? Subtract the y. Okay, this is as good as it's going to get, though. So now I'm ready to derive. The derivative of 3y is going to be 3 dy over dt. And the right side is going to be dx over dt. dy over dt is 4/9. Dx over dt is what I'm looking for. So what's my answer? Yeah, I'm just like saying, oh, that goes like that, 4/3. Okay? So hopefully some of this came back. Is